This exercise is called Factors Affecting Solution Formation. We're going to consider just what kinds of things we need to make a solution, make something get into solution faster or better. So in part one of this lab, we're going to take 4 equally sized pieces of copper 2 sulfate pentahydrate. It's this stuff, this same material we used in the water hydration lab. And since this is a qualitative lab, it doesn't have to be perfect, but I've got 4 roughly equal sized crystals here. What we're going to do is set up 4 test tubes. And let's start by putting the solvent, which would be water, in each of the 4 test tubes. So I'm going to take a deionized water bottle and fill each of these test tubes about halfway with water. So these test tubes are now equally full with water. They're all about halfway full. And we're going to treat each of the 4 test tubes differently. It's probably best summarized in the data table. So if you have access to the data table, go ahead and take a look at it. Of the 4 test tubes, 2 of them will have a full-sized crystal of copper 2 sulfate. The other 2 will have a crushed up particle of copper 2 sulfate. Then, between the first 2 test tubes where you have full-size particles, we're going to swirl test tube number 1, and we're going to swirl, of the 2 crushed particles, test tube number 3. So let's start by crushing up one of the crystals. So I'm going to take a mortar and pestle and crush the particle up into a fine powder. And the effect of that is to increase the surface area. For the same amount of mass, we're getting quite a bit more surface area of copper sulfate coming into contact with the water. And I'm going to add a crushed crystal to test tube number 4. And I'd go ahead and start a stopwatch right now for test tube number 4. We're also going to crush up one of the crystals to put into test tube number 3. So we have crushed up copper 2 sulfate crystals in test tubes numbers 3 and 4. And now we'll put the full size particles into test tubes numbers 1 and 2. I'm going to begin swirling now. I'm going to swirl test tube 1, which has a full-size crystal, and I'm going to swirl test tube 3 with a crushed up particle. Now swirling a test tube just means making little swirly motions with it, or any kind of an agitation. If you had a machine to do this, that'd be nice. But what we're going to do is time how long it takes each of these test tubes, the copper sulfate in each of these test tubes to dissolve. Now it might be a while, so I'm going to pause the video and then we'll come back and make observations. So the test tubes go 1, 2, 3, and 4.
Okay, students, check it out. So test tube number 1 was the one that had a full crystal that we swirled. Look at how blue this one is. By comparison, here's test tube 2, which we did not swirl. Which one dissolved more? Here, I'll hold it against the white background. Can you see definitely a deeper blue color in test tube 1? So we can conclude that swirling helps. We can furthermore compare test tubes 3 and 4. Now these are both pretty darn blue, but which one is more blue between test tube 3, which was crushed and swirled, and test tube 4, which was crushed but not swirled? Definitely test tube 3. So we've got evidence that swirling helps. Now what about crushing? Let's compare the 2 test tubes that were not swirled. In test tube 2, we have a tube that was not swirled and had a full-size crystal. In test tube 4, we have a crystal that was not swirled and was crushed up. So of these two, which one has more blue in it? Test tube 4. So crushing the particle, or thereby increasing the surface area, helps get things dissolved. Let's compare test tubes 1 and 3. Now this one might be tougher. We have a full-size crystal that was swirled. You can definitely see blue in it. But look at this one. Test tube 3 was crushed up and swirled. Of the two of them, which one has more blue in it? Test tube 3. So swirling helps and crushing helps get things dissolved. Now, let's think about that. Is there a theory that we can come up with? In order to get something to dissolve, you've got to have solvent particles come in contact with solute particles. There needs to be an exchange of particles. If you crush something up, you're increasing surface area, which means on average you're going to have more solute particles exposed to solvent particles. And when you swirl, you're moving around the solvent particles so that fresh ones that haven't yet come in contact with the solute, are able to come in contact. So it's all about exposing solvent and solute, mixing up. It's like a mixer at a dance. You want to mix people up in the hopes that you can get a solid combination, which is what a solution is. Okay, now we'll move on to part 2. In this second part of the factors affecting solution formation lab, we're going to just dissolve sodium chloride, good old table salt, in each of 3 test tubes. But this time, instead of testing particle size and swirling versus not swirling, this time we're going to test the effect of temperature. Hot water, room temperature water, and half hot, half room temperature water. So for a cold, a medium, and a hot temperature. Again, it's qualitative, so it doesn't, we're not going to bother recording the temperatures of the 3 test tubes, although that would be an area for further study. But this one, we're just going to get a qualitative measurement. So if you take a look at your data table, it's probably the best place to note what we're observing. At the low temperature test tube, let's make this test tube number 1. That's room temperature water. I'm going to half fill it with a deionized water bottle. With test tube number 2, I'm going to fill it a quarter full, one-fourth full, with water from the deionized water bottle. But then I've got this hot water sitting on a hot plate. It's boiling right now. And I'm going to use, because it's crazy hot, I'm going to use a dropper to transfer, so that I don't burn my hands, but I can still transfer the water. And that's about half full as well. So in the test tube 2, it was half room temperature water, half boiling water. In test tube 1, it was all room temperature water. In test tube number 3, it's going to be all boiling water. So we're simply transferring water of appropriate temperatures to each of 3 test tubes. That's going to be obviously the solvent, good old water. And let's one more squirt. Okay. So now we've got 3 test tubes about equally full, halfway, and we're going to dissolve an equal sized scoop of sodium chloride. I've got lab grade sodium chloride here, but table salt would do the same thing. So I've got a spoon with the sodium chloride poured out. I'm going to put roughly equal amounts. I'm going to get a slightly different device. One moment, please. Set the spoon aside. This should work better. I've got a nickel spatula. It's a little bit narrower to allow me to more precisely control where the solute goes. So I'm going to give about a scoop to each of the 3 test tubes. And then, as the directions say, I'm going to swirl the test tubes, gently swirling each one. One way to swirl, so you can
do this with your wrist, that would be fine. Or I've got a glass stirring rod, and you just agitate the water up and down a little bit. We'll do this for about 1 minute and see if we can notice any differences. A little bit of swirling here, do about equal amounts of swirling here. It is nice when you have multiple lab partners, you can all be swirling at the same time. I can tell already, I'll hold this up to you, but I can already tell that test tube number 3, the one that was boiling water, has completely dissolved. So if you look at, maybe go back to the sheet here. So if you look at this test tube, there's no solid particles at the bottom of it. In other words, it's completely dissolved. If you look at this tube, I think it just finished dissolving. So the one that was half hot water, half room temperature water, just finished dissolving. And the one that's all room temperature water, you can still see solid particles at the bottom. So if you were judging which one dissolves best, I'd say boiling water for sure is the fastest dissolver, followed by half hot, half room, followed by all room temperature. And again, what does that tell us? Can we draw a connection? If you think back to part 1 of the lab, we had concluded that swirling helps and crushing helps, and helps get substances dissolved. The reason for that is it's constantly exposing new particles to each other, solvent particles coming into contact with new solute particles. Well, in this case, temperature. Do you maybe recall back from freshman physics, the higher the temperature, the higher the average velocity of the particles. That means hot particles are moving faster. So if you've got hot solvent particles, hot water, the water is going to be moving faster, and a faster moving water molecule collection would have a greater chance of coming into contact with solute particles. It's all about molecular collisions in the end to get any kind of a reaction to happen, but that includes solution formation. And that was the point of the lab, is factors affecting solution formation. We want you in the lab report just to talk about effective particle size, effective mixing or swirling, same thing, and effective temperature. Explain as best you can how each of those 3 factors affects the dissolving process. Thank you for your attention.